So hey there guys, welcome back to my channel, and in today's video I'm going to talk about some more types of functions. As I had told you that you are going to get free playlist of class 11th mathematics, and here it is. So I think we have discussed what are the constant functions, okay, and we also discussed what do you mean by term called modulus function, and what do you mean by term called floor function, or you can say the greatest integer function, greatest integer function. And we also discussed one type of function, that is your identity function. Okay, if you didn't watch that video, please go to my playlist and watch that video and then come to this. So in this video I'm going to talk about some more types of function. I'm going to talk about four to five different types of function. Like the first, we are going to talk about, we have completed the floor function. Now we are going to talk about, or you can say, the greatest integer function. Now we are going to talk about what do you mean by term called smallest integer function. Okay, smallest integer function, or you can say it is a ceiling function. Okay, ceiling function. This function is just opposite to that of the floor function. Okay, so it says for any real number x, we use this to denote the smallest integer greater than or equal to x. Okay, as in greatest integer we have the greatest integer less than or equal to x, but in this we have what, smallest integer greater than or equal to x. Like for example, if we have 4.7, we have to find the smallest integer function of 4.7, then it is going to give your what, 5. Okay, remember, if you have a greatest integer function, then it is going to give you 4. I am already saying that if you try to reach the ceiling but somehow you are not going to reach the ceiling, then you are going to drop down from the floor. Okay, it is what your greatest integer function. But in the smallest integer function, what you are going to do, you are going to basically catch this from the ceiling. Okay, from the ceiling, from the floor. If you are getting cast, then you are going to go on the floor, but if you are not, you are already on the ceiling. Okay, so just remember that type of example. It is very confusing, but you have to remember that. Okay, so now what is minus 7.5? Okay, if we are having the greatest integer function, then it is going to give what, greatest integer less than or equal to x. Okay, so but here we are going to get what, minus 7. Okay, but in the greatest integer function we are going to get minus 8, because we are trying to reach 7.2, or you can say here you have minus 8, here you have minus 7, and you are trying to reach what, to consider this point that you have minus 7.2. As you know that in negative integers we are going to get minus 7 what, greater than minus 8. Okay, so if we are trying to reach what, minus 7.2 from the floor, but we are not going to catch it, okay, then we are going to drop entirely on the floor. Okay, and now considering the reverse, that we are going to reach from the ceiling minus 7, that is, to the floor minus 7.2. floor means that integer value. Okay, integer value, or you can say the ceiling is the integral value. So here the ceiling is what, minus 7. We are going to reach floor, but we are not going to get completely to the floor. The floor is your minus 8, so we are going still to what, we are still on the ceiling. Okay, so I think I made my point here clear. Just remember from this point. So now moving forward, I am going to draw the graph for smallest integer function. Okay, so it is entirely opposite to that of greatest integer function. So now plotting the Cartesian system. Plotting the Cartesian system. Okay. Drawing the points 0, 1, 2, 3, -1, -2, -3, 1, 2, 3, -1, -2, and -3. Okay. So I already told you that what if 0 to 1 you are already going to get the value of what? Smallest for any real number x we get this smallest integer greater than or equal to x. Okay, so remember, if you are going to drop to the value of 0 to 1, like for example 0 to 1 you are going to get, you are not going to get 0, remember. Okay, it is entirely in the greatest integer function. Here you are going to get this one. If you are going to put any value 0.1, 0.2, 0.3, you are going to get a smallest integer greater than. So the smallest integer is always is 1. It is greater than or equal to what? Your 0.1. So you are going to get this value. But at 0 you are not going to get this value. You are going to get 0 as here. Okay. So I think I made my point here clear. So now plotting this graph. So now plotting similar. If you are going to put any value from the minus side, you know that we have -0.5 or you can say -0.7. We are going to get what? Your smallest integer greater than. So only the smallest integer that is going to greater than -0.5 is your what? 0 here. Okay, so here you are going to get y as 0. If you are going to put x is equals to -0.5 or -0.7. But remember that you are not going to get -1 here. Okay, so y is not going to -1. So in this similar manner you can draw the graph, or you can see you can continue the graph. Okay, I have plotted for 2's, and now for 3 I can also do that. Like for example, if you are putting -1.5 something like that, -1.7, so the greatest integer that is going to be greater than is, if you are going to put x is equals to -1 or something like that, you are going to always get y as what? Can you tell me what we are going to do? What y is? You are always going to get y as -1, because you know that this is the smallest integer that is going to be greater than all the values of x here. So now putting the value here -1, no matter what x you choose except -2 here. Okay, so now you can plot the graph in a similar fashion. Okay, so now let me write this thing in a systematic way. Greatest integer function value is going to be -1 when you are going to put the value of x as -1 to -2 is equals to 0 when you are going to put the value of what? X as 0 to -1. Okay, 0 to -1. So I think I made my point here clear, and the smallest integer function is clear. Okay, so now moving on to another part of the function, that is your Signum function. What is that? Signum function. Okay, so before teaching you the concept of Signum function, let's revise what do we mean by a term called modulus function. As we have already discussed that is mod x. So no matter what the value of x we are going to put here, we are always going to get y as positive of x. No matter what x you put, either negative integers or 0 or positive, you are always going to get of positive of x. I think I made my point here clear. What is modulus function? If you want a detailed video, you can refer to my previous videos. Okay, so Signum function is entirely fx is equals to mod x by x when your x is not going to equal to 0, and 0 when your x is going to equal to 0, or you can say fx is equals to, so mod x, you know that your mod x is has two values like plus x of x when your x is going to greater than 0, or you can say when x is positive, or minus x of x when your x is negative, or 0 when your x is equals to 0. So now writing the final values of this, fx is equals to 1 when your x is positive and 0 when your x is equals to 0, and minus 1, okay, here you can see, when your x is negative. Okay, so now plotting the graph. So now plotting the graph, x0, 1, 2, 3, minus 1, minus 2, minus 3, plus 1, plus 2, plus 3. I think I plot the graph here correct. Yeah, minus 1, minus 2, minus 3. Okay, so for x is equals to 0, we have this point, and for x greater than, we are always going to get y as what? Your 1. So no matter what x we put, we are always going to get y is equals to 1 as constant. So y is equals to 1 as the constant is going to be a line parallel to x-axis. Okay, so now y is equals to something is a line that is parallel to the x-axis, and here y is positive, so it is line going to be parallel to positive direction of x-axis. Okay, so y is equals to plus 1, and here you are going to get, if you are going to plot, y as minus 1. Always remember that here is your bulb, that is not lighten. Okay, means what? That you are not going to include the value of x is equals to 0 here. Okay, so I think I made my point here clear, and I have also plotted the graph of the Signum function. Okay, so if you are trying to see what is the domain of the Signum function, the domain of Signum function is the set of all real numbers. Okay, and what is going to be the range? And your range is the set, what? You have basically 3 ranges, or you can say the image of the various elements that the fx is going to give. It is your 3 basically, that is minus 1, 0 and 1. Okay, if you don't know what is the domain and range of the function, please refer to my previous video before coming into this topic. And next, that I had already told you that we are going to deal exponential function and logarithmic function on a separate video, because they are one of the most important functions of mathematics, and I am going to give a separate time to these function, and the video is going to be 1 to 1.5 hours longer. Okay, so I think so now we are moving on to another function that we have is your what? Reciprocal function. Reciprocal function. So what is the reciprocal function? We know for any real number x, okay, for any real number x, we have what? Wait a minute. Okay, so for any real number x, we have 1 by x. Okay, so here remember that your range is going to be well defined when your x take any value except 0. Okay, so we are going to take the function defining from all real numbers except 0, because at x is equals to 0, 1 by 0 you know is not well defined. Okay, to real number fx is equals to 1 by x. So now plotting the graph. So now plotting the graph, here you can see that your range is also not going to be equal to 0. Okay, so there is no value of x that is going to give your range as 0, so you can also subtract 0 from this side. Okay, so now plotting the graph, as you know that if you are going to put 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, 1, 2, 3. Okay, so if you are going to put 1 here, we are always going to get 1, but if you are going to put, okay, so let's see, 1 by 1 for x is equals to 1 and 1 by 2 for x is equals to 2. Okay, so if you are putting x is equals to 2, we are going to get here and then 3 here, then just small points. Okay, so here also, that if we are going to put what 2, so now you can see that if you are going to put less than that x is equals to half, then you are going to get what 1 by half, that is your 2. So here you are plotting this, simply this. Okay, so if we are going to join this, we are going to get a what curve. Okay, like this. For similarly this side also we are going to get a curve. You can try also from putting the value of x as negative of integers, and you are always going to get what this type of curve. Okay, this type, which is trying to meet the axis but is not going to meet, like this. Okay, so here you can see that the curve is trying to meet the axis here, that is y axis and the x axis, but it can't. Okay, like this. So it is the graph of y is equals to 1 by x and x is not going to be equal to 0. Okay, so now moving on to another topic that we have is a square root function. What is that? What is the square root function? Okay, so we know that any function x which assigns the value of positive square root of x, okay, is called the square root function. So we know that it is going to be real. It is going to be real when your x is what greater than 0, or you can say x is positive. If x is going to be less than 0, we are going to get under root of minus x, which is what your imaginary. So we are dropping that set of value from this equation. Okay, so now we are going to define this function as f only from the positive side. Remember, we are not going to put the negative value of x to the set R of real values. Okay, so fx is equals to what positive of under root x is called the square root function. Okay, so what is the domain of, or you can say what are the possible values of x you can put here? You can only put the positive value, that is your 0 to infinity. Remember, you are not going to put any negative values in that, and its range is also going to be equal to what your 0 to plus of infinity. Okay, so plotting the graph like this. Okay, 1 2 3 1 2 3. Remember, no negative values are included, so don't plot the graph this side. Now at x is equals to 1, you know what is going to be that. For x is equals to 2, you have under root 2. Okay, and what is going to be the value for that? Do let me know in the comment section. And what is under root 3? You know, something 1.732. Okay, 1.414, something like that. So if we are going to plot this on the graph, you are going to get this type of, okay, this type of curve. Okay, so it is the graph of y is equals to under root x, or you can say y is equals to x to the power half. So I think I made my point here clear. What is the square root function? Now talking about what is the square function. What is the square function? Basically we can say that a function defined from real number to real number, and which takes the value x and throws it to your x square. Okay, so it is defined for all x belongs to R. It means for all. Okay, for all, and here means belongs to. So if you are plotting the graph like this, if x is going, so you here you can take negative values also, but remember, if you are going to take the x as -1, you are always going to get y is equals to -1 square, that is your +1. Okay, so don't plot this side. So 1 -1 -2 1 2 3 2 3. So here x is equals to 1, why we are going to get always as 1, x is equals to 2, y we are going to get as what? 4. Okay, so I haven't plotted the y as 4 on this. Just consider it here 4. Okay, so it is a curve like this. Okay, like this, -1 here and then -2 here. So plot this, I know my like this. Okay, so it is the graph for the square of the function. You can say y is equals to x square. Okay, so now moving on to another topic, that we have a cube function. Cube function is also going to be defined for all set of values of for real numbers. Like for example, we have function is defined from real numbers to real numbers such that f takes the value x and throws it to x to the power cube. Okay, as you can clearly see, if you are going to put x as 1, we are going to get 1 cube. If you are going to get 2, 2 cube, then 3, 3 cube. Okay, as we are increasing x, we are going to get increase in value of its range. Now plotting this graph, so now plotting this graph, this will look like entirely like this, similar, but there is a little bit of changes in that. 1, 2, 3. So for 1, 2, 3, 4, 5, -1, -2. Okay, 1, 1. If you are going to put 2 here, we are going to get 8 something around here. Okay, so joining this point, we are going to get this type of graph. This. Similarly, extending it to that side, we are going to get this. Okay, like a snake type of graph. Okay, for -1, we are going to get here -1. Okay, and for -2, we are going to get, I think I draw this extended to. Okay, because for -2 we are going to get at what? 2 to the 4 to the 8, and -8 is around here, so it is going to mean something like this. Okay, I know my Apple Pencil, there has been a lot of difficulty in drawing using Apple Pencil like what? This. Okay, if you want a clear explanation of this, you can I am also going to drop some videos for that. Minus like this. Okay, so this is the graph for what? Y is equals to x to the power cube, and it is your homework to draw the graph for cube root function. Okay, draw the graph for cube root function. I am just saying that if you are going to take any real values and put x in that, you are going to get x to the power 1 by 3. Okay, so it is your homework to draw the graph. I am just giving you the hint. For cube function, you can say you have to draw some, like go to -1, -2, and go till -8. Okay, -3, -4, -8. Okay, so if you are going to put 1 here, we are going to get 1 to the power 1 by 3, and for 1 we are going to get 1 to the power 1 by 3. You can let me know in the comment section what is the value for that. Okay, and for x is equals to 8, we are going to get y is equals to 2. You can clearly see why. Okay, so if you are going to put x is equals to 8, you are going to get this value. So plot the graph this as your homework. Okay, so now we are concluding this chapter by letting some basic operations on real functions. Okay, operations on real functions. Okay, so if you have given two functions, namely f defined from domain 1 to real numbers, and another function g defined from d2 to real number. Okay, fx is equals to x and gy is equals to y. Okay, it means that f is going to take the value of x and is going to through this point. Okay, always remember that your sum, that is f plus g, is always going to be defined for the points that are common to both the domain, for both their domain. Like for example, f plus g is only defined for d1 intersection to d2 to R. Remember that they are only defined if x belongs to what? Their common domain d1 intersection d2. So first you have to make x common to both their domain, and then you have to do some other calculation. Similarly, for subtraction, f minus g is defined only for your x belonging to d1 intersection d2. If you don't know what do you mean by term called intersection, please refer to my previous video to R. Okay, I think I made my point here clear. So f plus g x is equals to fx plus gx. Okay, f minus gx is equals to fx minus gx. And similarly, you can define for multiplication and also, yeah. So now moving on to another topic, that is your multiplication of function. If you have what to f1 defined from d1 to r, and your g is defined from d2 to r, then you have f g. Okay, remember that there is a lot of difference between fg and f composition with g. Okay, I'm going to make these points clear in the next video why they are different. Okay, both are very different, so just remember that your point can make a lot of difference in that. So the composition fg is equals to what? Fx dot gx for all. Remember that s must be belong to the point common to their domain. Okay, similarly for your quotient to quotient, okay, f by g x is equals to fx by gx. Here it is a twist that your gx must not be equals to 0, because if it is going to get equal to 0, then fx by 0 is not defined. Okay, so for all x belongs to d1 intersection d2. Okay, I think I made my point here clear. So this is what your sum, subtraction, multiplication and quotient. And if you are going to multiply a function by a scalar, then if you have to multiply a f x, it is going to be same as alpha multiplied by x. Okay, or you can say here we are putting alpha. Okay, multiplication of a function by a scalar. A scalar can be any real number, you can say. Okay, a scalar is nothing but you can say 1, 2, 3 multiplication by a scalar. Like for example, you have alpha f x is equals to the same as alpha fx. Okay, for all x belongs to domain. Okay, so now I am giving one example how you are going to find the sum and difference for the identity and modulus function. It is your NCERT question basically. Okay, example, find sum difference of fx is equals to x, your identity function. If you don't know what is the identity function, refer to my previous video. And your what? Gx is equals to mod of x, your modulus function. Okay, it is your modulus function. So we have to find the what? Sum and difference. Okay, so we know that for identity function, that is your fx is equals to x, we have f defined for real numbers to real numbers, and for modulus function gx is equals to mod x, we have your g defined for real number to real number. You can say that x is common to both their domain. Okay, they have, you can say, same domain. X belongs to their common domain. So now you can carry on the procedure as usual. Like for example, if you are going to add these two, you are going to get what? F plus g x is equals to fx plus gx, x plus mod x. Okay, so x plus positive of x, x minus positive of x for x greater than 0 and for x less than 0. I think I made my point here clear. So here you are going to get f plus g x as your 2x and 0 for x greater than or equal to 0 and for x less than 0. Okay, so I have done the first part, that is your addition, and you can also do the same part on your own by doing the subtraction procedure. Okay, modulus function is always going to give two values for x, but the y is equals to mod x is always going to give the positive values of x. Okay, so I think I made my point here clear, and if you have any doubt, please refer to my previous videos. And if you have any inquiry regarding live classes, contact me on 870-754-9139. Or you can also mail me at the rate Tanishq Trivedi Edu at the rate gmail.com. If you like my video, do like, comment, subscribe, and share among the videos. Thank you and have a great day. So let me fill this with the red one. Okay, so now thank you.